My fifth graders responded to division just like they did years before to addition and multiplication, with nervousness and apprehension. Through introducing them to a multitude of strategies, and by employing the social constructivist theory of learning, where assistance and scaffolding from me is provided and then slowly removed, along with students working together and building from each other's ideas, we ended up with a pretty solid understanding of what division is that we can continue to build on. So with the help of my students, we present you with, these are the ways to divide. We started by explaining the division vocabulary, dividend, divisor, quotient, and what those words meant. Knowing that the dividend is the number being divided into groups by the divisor helped them to see the relationship multiplication has with division, which brought them to a strategy that made sense to many. By using the using multiplication strategy to divide, students were able to turn their problem around to a multiplication problem and use multiplication easily to solve the division problem. This is also the one they found the easiest to talk about with each other in their group. The long division or traditional method was also modeled because this will be how they get their assistance and support at home. Plus, this method is very cut and dry for many students, especially those with outstanding mental math abilities. I have many students who actually prefer this method over the other drawn-out methods, or those that use a pictorial representation. The next strategy we modeled was to simply put your divisor into groups to see how many groups you would have. This strategy will lead us into our next one that is supported by our Investigations Math curriculum. I sat with a group early on as we walked through and worked on a division problem together. Here is our conversation, which includes the majority of the talking being done by me.
Okay, so this is 175 divided by 12. What are we going to do to solve this problem? We have
to divide it.
Okay, what does that mean?
I don't know.
Who has any thoughts on what it means to divide it up?
What if we did
to multiply it? Well, we don't want to multiply because division's the opposite of it.
What if we did 21
times
blank equals 175? That's what? Oh, my bad. What if we did 12 times blank equals 175?
So we're going to change our division into multiplication. So now we got 12 times something equals 175. So what number could we do? 12 times
10.
What? 10. Sweet.
12 times 10?
Okay, what's 12 times 10 going to be?
125.
Well, it's not 175 yet. So write it below. Wisdom said 12 times 10 will be what?
110. 120.
So, how many more do we need to make 175? What's 120 plus
50,
what?
Yeah, 50.
50? 55. So how many more 12s can we use to make 55? 5. And 12 times 5, we'll see what that is. Is what?
60.
60. So Jalen just said that's too high. So it can't be 12 times 5. Because it'd be equal 180. So if 5 is too many, what would be just right?
12 times 4.
12 times 4. So let's see.
Now we should add 20 with 48. 20
plus your 48, he said. Because you did 12 times 10, and now you did 12 times 4. So let's see what that makes all together. So 12 times how much made 168?
12 times 15.
Not 15.
14.
So we know that 12 times 14 is 168. Can we add another 12 to it, or does that give us too many?
That gives us too many.
So how many do we have left over then? There's 7 left over. So 12 times 14 equals 168 with 7 left over. So what would 175 divided by 12 be? What number is that? 14. 14 with what's your remainder? 7. Beautiful. So that way, the way you chose just now to do it, you used your multiplication skills to help you turn it around and divide.
Our next division strategy is right from our Investigations Math curriculum called Multiple Towers. Students create towers using the interlocking cubes for the divisor and see how many towers they can make. As a student explained it to the class, he said that 105 divided by 21 You count multiples of 21, and you write each of those numbers down without going over 105. And then you just count how many numbers, or towers of 21, you wrote down. Again, this is using the student's prior knowledge of multiplication to solve division. We also used the social aspect of the students as we played a game called Division Compare that is also from our math curriculum. Students were in pairs and each drew 2 cards. They worked together to help each other solve their division problem and decide whose quotient was bigger, and talk through how they solved their problem and got their answer. This is great for the social constructivist model because students are sharing what works for them and giving each other ideas about what to try for themselves. Plus, they are teaching each other, while I am supporting where and if needed. About a week later, I returned to my original group to see the progress they had made with their ability to divide and talk through their strategy together without me. Now the scaffolding is being removed. Here is their conversation.
Now that we've been working on division here for a little while, let's come back together and try a different one. So this is 289 divided by 24, so we're going to make even bigger numbers. So now that we've been working on it, you guys talk with each other.
First, we are going to do 24 times 10, and that equals 240.
And then we should do 24 times 2, which equals 48. And then we should add those two together, and it'll equal 24 times 12, which equals 288.
And that's our remainder of 1. So that means 12 times 24 equals 289, but that would be remainder of 1.
Hold on. No, the answer is 288 with the remainder of 1.
Right.
That's correct.
And if you're multiplying, you're dividing, so it's 289 divided by 24 equals what?
12 with the remainder of 1.
Very good.
The second conversation shows a distinct difference in where the students started and where they are at now with division. It also shows how their understanding has developed and their ability to talk with each other and utilize all known methods rather than turning to me when they need help. Our division learning is far from over, but to bring this introductory unit to a close, students grouped up to create their own division poster. They made up their own problem, story to go with it, and explained their thinking and strategy used. Here is one student as she explains the poster that she and her partner made.
We made these division posters to kind of show what we've been learning about division. So I want you guys to just kind of explain to me what it is that you did of your division problem.
I put 14 into groups to see how many times I can put it into 190.
So how many groups did you end up with?
13.
So that equaled out to be how much?
How much? 182.
So then again, did you have any left over?
Yes.
How many?
8.
8. See, in your example, what I wrote here on the back, yesterday when we did our multiple towers, so basically you counted by your multiples of
14.
14. So that's kind of goes right along with what we worked on and did yesterday.
Yes.
As we continue our division learning, students will continue with the social constructivist model and utilize each other more for assistance and help and require less support from me. I will become the guide on the side rather than the sage on the stage, as students construct knowledge from their already social tendencies of conversation.